In this class, we'll be discussing two important concepts. One is how to balance the chemical reaction and what is limiting reagent. So let us discuss these two important aspects in chemistry. Let us go into the subject now. Ammonia combines with oxygen to form nitrogen oxide plus water. In this experiment, 3.25 gram NH3 are allowed to react with 3.5 gram of oxygen. Now the questions asked here are: which reactant is the limiting reagent? How many grams of nitrogen oxide are formed? How much of the excess reactant remains after the reaction? So we need to discuss these three answers. So before attempting into the solution, we should be able to arrive at the balanced equation. That is, we should be able to balance the given chemical equation. So the equation is ammonia combines with oxygen to give nitrogen oxide and water. So let us adopt the oxidation number method to explain or to arrive at this balancing of redox reaction. Before that, we should be able to determine the oxidation number of the element that undergoes change in the oxidation number during the redox reaction. So we need to identify that first. Let us consider ammonia. So ammonia, where plus 1 is the oxidation number of hydrogen, and for any neutral molecule we know that is 0. So here for neutral molecule of ammonia the oxidation state is 0, and we had to calculate this nitrogen, the oxidation number of nitrogen. So here if it is a plus 3, so we can write x plus 3 is equal to 0. Therefore, x is equal to minus 3. So this is the oxidation number of nitrogen in ammonia. So that we have indicated here. And then oxygen for neutral molecule, oxygen that is 0, oxidation state is 0. Now let us work out nitrogen oxide. So nitrogen for oxygen it is minus 2. Therefore for nitrogen it is plus 2, so that the neutral is 0. So the nitrogen in this case is plus 2. And for water we know H2O. So for oxygen it is minus 2. Okay. So now we need to identify which element undergoes change in oxidation number. So hydrogen, this is plus 1, this is also plus 1. Oxygen is 0, whereas in this case it's minus 2. And similarly nitrogen, this is minus 3, here it is plus 2. So we can conclude that is nitrogen and oxygen have, that is undergone some change in oxidation state, that we will identify. So nitrogen with oxidation number of minus 3 in ammonia undergoes what? A change in oxidation number. This is minus 3 and this is plus 2. So minus 3 becomes plus 2 means whether it is an increase in oxidation number or decrease in oxidation number. Naturally, it is increase in oxidation number. So oxidation means what? That is de-electronation, drop in electron. So it means minus 3 has become plus 2 means 5 electrons are dropped here. So de-electronation occurs. Are you able to follow? So it means that is minus 5 electrons. So this undergoes oxidation. What is that? This undergoes oxidation by the loss of electron. Do you understand? Right. Then what about oxygen here? This is 0 and it has become minus 2 in this case. So there is an addition of electron. Okay, this undergoes reduction. Therefore, there are two electrons, and for each atom, two electron means there are two atoms, so 2 into 2, 4 electrons we need to count. Now we have this 4 electrons and here 5 electrons. So we have to interchange the number of electrons as the coefficient of the respective, the other, that is moles of reactants. Therefore, here we have 4NH3 because here we have 4 electrons, so we can exchange 4 coefficient. Molar coefficient is 4 for ammonia. Similarly 5, and you can put 5 in front of oxygen as molar coefficient. So 4NH3, 5O2. Then we have to adopt the ERP technique, that is element, reactant, product we will work out. And you can list out the elements here, then reactants here and products here. So what are the elements? NHO. And on reactant side, how many nitrogen atoms are there? There are, you can work out here, that is only 1. So 1. But we have put 4. So 4 electrons. That is 4 nitrogen. And what about this nitrogen on the right side? It has got only 1. So we can multiply by 4. Okay, so that we can balance it. Now we have balanced. Then hydrogen. So hydrogen is, how many hydrogens are there? That is 4 into 3 because we have got 3 into 4, 12. So you can put 4 into 3. And in this case, that is hydrogen is only 2. So 4 threes are 12. We had to balance it. You can put 6. So that 6 twos are 12. Now it's balanced. And the leftover is what? Oxygen. So how many oxygens are here? 5 twos are 10 oxygen. And here 4 plus what? 6. So 4 plus 6, 10. So all are balanced. So in such a way, this should be balanced. So first we have to balance the redox reaction. Okay, right. Then let us move to the next part of the problem. Here, now after balancing, look at this. 4 moles of ammonia combined with 5 oxygen molecules to give 4 moles of nitrogen oxide plus 6 moles of water. Now let us put the molar coefficients here. So 4 mole, 5 mole, 4 mole, 6 mole, and its respective molar mass can be written here. So what is the molar mass of ammonia? 17 gram per mole. For oxygen, 32 gram per mole. For nitrogen oxide, 30. And for water, 18. Now this is N and this is the M, molar mass. Okay. Now we know that is by multiplying this we can get W because we know the equation number of mole is equal to weight by molecular weight. So if you need weight, you can multiply number of mole into what? M, molar mass. So based on this, we can multiply this. So 68 gram. This is the theoretical weight. WT means theoretical weight. Similarly, 5 into 32, 160. 4 into 30, 120. 6 into 18, 108. Now, the given weight should be taken. This is the actual weight and this is the theoretical weight. This is the actual weight. So, 3.25 gram, that is the quantity given in the problem, 3.25 gram ammonia and combines with the 3.5 gram of oxygen to give nitrogen oxide, and so we need to find out these two. So according to mass ratio, there is a concept called mass ratio. So the weight ratio is always equal. For instance, 68 gram divided by 3.25 gram. Okay, so we can compare this. And what about this? 160 gram divided by 3.5 gram. And 120 divided by X. And 108 divided by Y we can put. Now, our idea is to compare. Now let us compare these two. Okay, and similarly we can compare these two. So let us compare these two. Let me say this is x2, x1, and this is x2, and this is y2. Let us go for the first one, x1. 68 divided by 3.25. 68 divided by 3.25. So 120 divided by x1, let us put x1 and we will find out. Then we get x1 is equal to 5.73 gram. And by comparing this, so this is x2. So 160 divided by 3.5, 120 divided by x2. So x2 we are able to get 2.5625 gram. Okay. So what do you mean by x1? X1 is that is the weight ratio of what? That is, I mean weight of nitrogen in this case. Okay, nitrogen oxide x1. When you take this one, this is 2.625 gram. That is x2, the other one. So when we take, listen to me, when we consider this becomes what? X1. When we consider this, okay. So likewise we have to do. So first you have to work out like this. So this is the first one, 68 gram divided by 3.25 gram, and this one. And the next one is you can compare these two, that is 160 divided by 3.5. This should be compared. So when you compare these two, okay, based on the weight, I mean, we are working on two reactants. One is ammonia, another is oxygen. So we are working on based on ammonia, and what is the value of what? Nitrogen oxide obtained. From this we are able to get to 5.73. And by working the what? That is oxygen, we get the same oxygen, nitrogen oxide is 2.625 gram. So we get two values of a nitrogen oxide, that is weight of two values based on ammonia and this one. And when you consider this, which should be compared, this is a big question, is it not? So when we compare the amount of product, that is particularly in this case NO, obtained from the weight ratio of ammonia, that is from here it is X1 is 5.73 gram, whereas from oxygen it is 2.625 gram. It means the amount is less in this case, so we need to consider oxygen as the limiting reagent. And we cannot stop only with this. Now we can proceed, and we should know what is a limiting reagent first of all. The reactant which gets consumed first limits the amount of product formed is called limiting reagent. So when we compare the oxygen, I mean nitrogen oxide obtained from, that is ammonia, is what is the value? Let us say that is in this route we get x1. So x1 value is 5.73 gram, the nitrogen oxide obtained. The same thing from oxygen is, by dividing this we get how much? 2.625 grams. So it means it has a lower value. So it should be, that is oxygen is the limiting reagent in this case. Okay. Now we need to find out the excess reactant. The excess reactant we can calculate. We can do the reverse calculation. Now we know the other one is available in excess, that is ammonia 4NH3. So this 4NH3, that is based on that we can work out. Now let us have, assuming that is we have got this value only, that is 2.625 only. We get only 2.625 only, and then 120, that is the mole. So 120, and for nitrogen oxide. Then let us consider this 68, and let us assume this is, yeah, Z. So Z. So we can reciprocate. So Z by 68 is equal to 2.625 divided by what? This 120. 120. Now Z value is 1.4875. So the Z value is 1.475, and the original value is 3.25. So the excess amount of ammonia present in this reactant is 1.7625 gram. So this is the excess amount of ammonia. Okay. So likewise we should be able to calculate what is the excess amount of reactant. So ammonia is excess reactant. How much is excess? 1.7625 is in excess. Clear? So what is the limiting reagent here? Oxygen is the limiting reagent, And what is the, excess reagent, excess reactant, ammonia is excess reactant, and how much it is in excess? It is 1.7625 is in excess. Okay, clear? So let me summarize once again. See, we have got the balanced equation. First thing, we had to do the balanced equation. We had to balance the equation, then put the molar coefficient as such, 4 moles, 5 moles after balancing 4 moles of and 6 moles of this. Now, let us target, they are asked only based on, nitrogen oxide. So, nitrogen oxide here, 68 gram, ammonia theoretical weight by multiplying this we get 68 by multiplying these two we get 160, so likewise we get 120, 108, and the actual weight is 3.25 of ammonia and 3.5 of oxygen. Now we are doing a serious exercise of mass ratio, so this ratio is equal to this ratio, and this ratio can be compared here. So in both the cases, let me say, when we go like this, we get the value of NO as x1, here as x2. So when we do this calculation, mass ratio means the ratios should be constant. They are equal. So based on that we work out, and x1, x2 are compared for NO. So on comparing, we get x1 5.73 gram, x2 2.625. So which is the lowest one? This one. So we cannot take this. We have to take only this. So this is the lower one. So that is the amount of nitrogen oxide possible from this reaction. Okay, so amount of nitrogen oxide obtained in this, and which is responsible, how we are able to get, when we take this one here 5.73 gram of nitrogen oxide, but when we take the root of amount, oxygen, we get only 2.625. So we had to consider only this. So based on this, we have to proceed. So this should be, that is the relevant reactants, that is oxygen. So oxygen is the limiting reagent, and which is the excess reagent? Ammonia is the excess reagent. And how much amount is in excess? Now we have to back calculate, hiding this, taking this quantity as Z and find out Z. So we got the Z value, and by comparing these two, and this value should be incorporated here. So you have to incorporate x2 here. Okay, incorporate it. So 120 divided by x2, that is this much, is equal to 68 divided by, put Z. So find out Z value. So Z value is obtained here. So the excess reagent is 1.7625. Okay, right.